So now the question is, how do we do subnetting actually, right? So here I will just take few examples and just show it to you how the subnetting has happened. You will have to okay. So this is our example, right? This was our example 192.168.0.0/24. So what I'm saying is that this was our IP address 192.168.0.20 0.0. So this is how you will normally write your IP address. If you had a subnet mask of /24, your first 24 bits will be your network bits. And but for subnetting, what we will normally do is we will borrow one of the host bits. So we had these 8 host bits. So what we will do is this red color is showing that we had borrowed one host bit to the network side. Okay. So now with the result, we have got now 25 network bits instead of uh, 24. Now, as soon as we do that, what happens, right? So if you will see this particular range, okay, or rather, I will say this particular thing. So this particular bit, that is the borrowed bit, right? If its value is 0, then the range, the lowest IP address and the highest IP address that you can get with this kind of a combination is 192.168.0.0 to 192.168.0.127, right? So this is actually your becomes network 1. Now, the, the next IP address, that is after 127, the IP address that will come is 128. Now, the moment you reach to the IP address of 128, what happens is the value of your network bit is changing. Earlier it was 0, now it is 1. The moment the value of network bit changes, it becomes a new network altogether. So that is why we, instead of one network, we will now have two networks. And this will be the range of the first network, and this will be the range of the second network.
Yes, yes.
Okay. Similarly, there can be a scenario where we want to create, say, this was example of creating two networks. There can be an example of creating four networks in which we will borrow 2 bits. So again, the first case where the value of our network bits remains 00. Okay, this will be the range. Then the next network will have the values as 01, the network bits value. And again, this will be the range. In that third scenario, the network bits will be 1 and 0, and this will be the range. And the last one is our network bits will have value of 1 and 1, and this will be the range. So the fundamental concept is very simple, that whenever for subnetting or to understand subnetting better, if you can quickly write your IP address as in a decimal representation or decimal binary representation, you can easily make out why this particular IP address and this particular IP address are in two different subnets. Because the reason is my network bit value has changed. And once my network bit value has changed, it means that I am talking about a different network altogether. So this is the entire concept of subnetting. Uh, Using this, you can create multiple networks. You can have a scenario in which you break your class C IP address into, say, 16 networks also, uh, or maybe, and each network will then have, say, four IP addresses. That is possible. You can create two networks, three networks, and also there is one, when you talk about VLSM, right? There can be an opposite scenario also. Okay, variable length subnet masking, as we called it. So say you had an class C IP address like this, where I'm just giving you an example of it, where the IP address was 255.255.0.0, right? I'm not taking an example of subnet mask IP address, but I'm just showing it to you using a subnet mask only. So this was our normal class C subnet mask. Now, this is a scenario where your company had, say, 250 computers, or maybe your organization had 200 PCs with you, so you were very comfortable in using a class C IP address, and suddenly 200 people more have come. So now you have to provide uh, IP address to 400 PCs. Now you know, using a class C IP address, I cannot allocate more than 254 IP addresses, 254 devices. So either now you will say that, okay, let me move to a class B IP address, or what you can simply do is you can move to a subnet mask of 255.255.254.0, right? What you actually are doing is you are doing thing. You are borrowing a bit from network side to the host side. So with the result, your new subnet mask will become this, and the number of hosts in each, you will be able to take the number of hosts to, I think this will be 2 raised to the power of 9, which will be, I think, 512 or something. Okay, so even this kind of uh, this will not be called class class full subnetting. This will be called classless subnetting, right? So now this particular IP address you can use, and you can allocate more machines to your same network. The question goes like this: that you have an interface of a router with an IP address of 192.168.192.10.29, including the router interface. How many hosts can have IP addresses on the LAN attached to the router interface? So I will just try to summarize it for you. So see, we saw this example, right? We saw this example uh, when we borrow. So when we do subnetting, right, we are borrowing bits from the host side to the network side, right? So this is my slash 26 in which I have borrowed 2 bits. So by the default number of network bits are always 24. We are talking about class C IP addresses here. So say what happens if I borrow 1, 2, 3, 4, 5 bits, right? So this becomes what? This becomes slash 29. Very typical of our example. Okay. So now in this particular scenario, this entire thing becomes our network ID. So we are left with how many bits? We are left with 3 bits only. Okay. So when we are saying that we are left with 3 bits, so how many hosts can be there now? How many hosts per network? Right? So that will be 2 raised to the power of 3. That is equal to 8. So you see in this particular example, say this entire thing, right? This entire thing is an example of a single subnet of slash 29, in which all these are the possible 8 IP addresses. Okay. So this is example of 192.168.123.0, right? And it will go till 7. 192.168.123.7. So this 111 will nothing but the 7. Okay. So what we are saying is that as soon as we take a subnet mask of slash 29, I do a subnetting in a way that each subnet that is created will only have 8 possible IP addresses. Since we don't use our first IP address and the last IP address, the first is always identifies as subnet number or network ID. So 192.168.123.0 becomes our network number or network ID. 192.168.123.7 becomes our broadcast ID. So the remaining 6 IP addresses are the usable IP addresses. Okay. So in our question, as we said that uh, the router already had one IP address. So the out of 6 usable IP addresses, I can have 5 more PCs. So if I will take this example only, how many subnets will be created? So suppose I am using a slash 29 IP address. So I told you in every subnet there are 8 IP addresses, and in so now my question to you is how many subnets are getting created? How will you answer that? Anyone? If I am using a subnet mask of slash 29, how many subnets I am creating? So 32 subnets I am able to create. So if you can see here, total subnets will be 2 raised to the power of 5, and that will be 32. And each subnet will have 8, or rather than 8, it gives us 6 usable IP addresses.